Yeah, this talk is for Oracle DBAs primarily. So about me, my name is Srini. I have around 17 plus years of DB experience. I worked at places like Apple, One Identity, Credit Karma, CDW, nationwide before, and then I'm currently a founding engineer at CloudDB. So the agenda is here. We'll start with architecture comparison, and then we move to shutdown startup modes, and then config changes, backup, compare, alert log, Postgres security, tuning scenarios, HA, and there's a ton of content, like 100 plus slides, so I'll be going really fast on some of them. And this talk is mostly for Oracle DBAs. If you're already a Postgres DBA and a Postgres expert, you might not gain much. And if you're okay, we'll take the questions at the end of the session. So to begin with, we'll discuss about the DBA role and how it is evolving. So the traditional role of DBA no longer holds good, as you know. Here are some of the quotes that we captured from various sources. So Jonathan Lewis, Oracle expert, he says that he's worried about the future of Oracle DBAs. Either we adapt or we slowly fade away. I was a DBA too, but I made transition to DBE. And major technology trends are reshaping DBA role. Oracle SQL Server DBAs should learn open source like Postgres, MySQL, DevOps like Ansible, and the cloud technologies. Even RDS Aurora needs database engineer, especially when you have too many RDS instances. And then if you look at the article on the right, the Cloud ate my database. This was one of the articles that got published recently, which says that cloud is eating database or DBA role. And then the death of DBA is a popular phrase these days. But nothing to be worried, DBA is not going away, but it is evolving. So here is an illustration we came up with. So the traditional DBA role no longer exists, and you need to learn multiple technologies. For example, on the top layer, you need to learn Oracle, open source, Mongo for NoSQL or DynamoDB, and RDS, Citus, Timescale, etc. And then the next layer is clouds, of course, AWS, Azure, Oracle, GCP. And DevOps is also one important area for DBAs these days, like Ansible, Terraform, CloudFormation, Jenkins, and then Python, Bash, etc. for coding. And last but not the least, the migrations, right? Like how do you migrate from on-prem to cloud, Oracle to Postgres, serverless, etc., Kubernetes. So as you can see, there are a lot of skills to learn. Of course, not everyone can learn all the skills, at least a subset, right? Like a few of them should hold good. And then we'll start the comparison series between Oracle and Postgres. So the Oracle has these components in SGA, like shared pool, database buffer cache, redo log buffer, Java pool, large pool. So when you compare that with Postgres, here are the components for Postgres shared memory. There's shared buffers, wall buffers, commit log buffers, memory for logs, and other buffers. And then side-by-side comparison between Oracle and Postgres for global memory areas. And the comparison of the memory parameters between Oracle and Postgres for some memory areas. The next slide is about the background process. On the left column, you have a different process in Postgres, like the checkpointer, logger, wall writer, etc. And the right column has the description of each of them. And here is a quick side-by-side comparison between Oracle and Postgres. The checkpoint is equivalent to checkpointer, log writer is wall writer, and so on. And here is the high-level architecture diagram for Postgres. On the left side, the client is going to talk to the postmaster process or the main process, and the postmaster in turn is going to spawn a separate backend process for each connection. And then on the top right, you have the memory areas, like the shared memory components, like shared buffer, wall buffer, etc., as we saw in the previous slide. And then in each connection gets its own private memory, like workmem for sorts, tempdef, catalog cache, and Postgres uses OS cache, as you know. And then, but Aurora doesn't use, only the on-prem Postgres uses OS cache, and then the list of background processes. Here is another important concept for Postgres, if you are new to Postgres. So Each client connection gets its own client backend process. As you can see, there are 5 different client connections here, and each of them gets its own client backend process. On the top, you have the block for the background process like checkpointer, etc. we saw in the previous slide. So that remains constant because they keep running all the time. In the next slide, we have 10 client connections. You can see the number of client backend process increased to 10 now, but the background processes block stays the same. Another important concept in Postgres is 1 GB segments. The data file in Postgres is split into 1 GB segments. So what is this number, right? What is this 65485, right? So this is called rel file node. So each table gets its own unique file ID, which is called rel file node. And then this table has 65485 as the ID. And since it's around 4 GB, we have 4 different 1 GB segments. So let us illustrate that with the example, right? So in this case, as you can see, there is a pgbench accounts table. The size of the table is 13 megabytes or it's under 1 gig, right? So if you see the arrow below, we only have 1 GB segment, one file, because the size is under 1 GB. So when we compare the previous slide with this, we loaded some data and the table size is around 3 GB now. And as you can see, the number of 1 GB segments is 3 in this case, right? So let's say you have a large table, you would see ton of 1 GB segments. That's a different concept in Postgres when you compare to Oracle. So the Oracle default table spaces are these, like system, sysaux, users, undo, temporary. And in Postgres, you only have 2, pgdefault, which stores all the user data. Like let's say you create a table without specifying a table space, it goes to pgdefault. And then the pgglobal stores the global data like pgdatabase, table space, etc. And then quick side-by-side comparison. System table space in Oracle is equivalent to pgglobal. And undo, we do not have undo table space in Postgres because Postgres uses different MVCC. And then the users, the equivalent is pgdefault, sysaux, there's no equivalent here. So let's move on to the next topic, startup and shutdown modes. As a DBA, you need to shut down sometimes for maintenance. How do you do that in Postgres versus Oracle? So Oracle, you have 4 different shutdown modes. So the normal one waits for everything, right? So, and then the transactional one waits for transactions to complete. Immediate doesn't wait. Of course, it starts terminating connections and it forces the checkpoints and closes files. But the abort one is the most dangerous one. Obviously, you don't want to use that in production. It's equivalent to a power plug pull, right? And then the shutdown modes in Postgres, we only have 3. The smart, which is equivalent to the normal in Postgres. Fast is equivalent to immediate. But the one big difference is immediate is equivalent to abort. So that's the confusing part for Oracle DBAs. So the comparison diagram again, immediate in Oracle is Postgres fast. Abort is equivalent to immediate. So Oracle DBAs, please do not use immediate because in Postgres it's different. So how about startup, right? These are different stages in Oracle startup, like you can open it in no mount, mount, open, etc. And this diagram illustrates what happens at each stage. In Postgres, you do not have different stages like no mount, mount, right? So you just issue startup and it allocates shared memory segment. And then it checks the PG control file to determine if a recovery is needed and which has the latest checkpoint information. If a recovery is needed, it performs the recovery and it starts the cluster in read-write mode. So comparison again, there are no mount, etc. in Postgres, and Oracle provides intermediate states and offers flexibility. So the next topic is parameter changes. So how many of you are Oracle DBAs, if I may know? I didn't ask that question, sorry. You're all like Postgres?
I know very little about Postgres.
MySQL, okay. So yeah, parameter changes are important for DBA. So how do you check the the location of parameter file in Postgres, you can use a command like show config file. So the equivalent in Oracle is show parameter sp file. So one of the important things, right, basically you're all MySQL users, right? You want to check the value of a particular variable, you do show global variables, right? Similarly, in Postgres, you can use PG settings. Like in this case, I want to search for a variable that has a shade in it, and then I use the select name settings from PG settings. In Oracle, the equivalent is with $$ parameter. And then you can also use show command. Let's say you don't want to use the $$ parameter or PG settings, you can use a show command, and here is the comparison. And then the other thing is you want to check whether it's static or dynamic, because dynamic variables you can change online, right? So how do you do that in Oracle? You can query $$ parameter for the column is modifiable, and in Postgres, you can check the context column in PG settings. So if the context has a postmaster, that means it needs a restart of Postgres. And once you determine whether it's static or dynamic, you want to change it. How do you change for static, right? So for Oracle, you do alter system set and scope equal to sp file, and then restart Oracle. In Postgres, you do use the similar command, or you can edit the config file and restart Postgres. And for dynamic, in Oracle, the scope changes to both. And in Postgres, the only difference is you issue that command select pg reload conf for dynamic parameters. You don't need to restart Postgres. And then here is another slide to check if it is modifiable at session level or not, because some parameters are modifiable at session level. And then once you determine if it is modifiable at session level, you can use a command like set session. And this is an important slide if you want to learn about the parameter changes in Postgres, because Postgres allows you to do parameter changes at different levels: cluster level, database level. If you have multiple databases but you want to scope the change to a particular database, you can do that. User level or role level, transaction level, etc. And then another important slide. So once you build Postgres, don't use the default config. I think it's true in Oracle or MySQL, right? Some of the parameters like shared buffers, max connections, etc. are not good enough. I mean, you need to determine what is good for your use case and customize it. And here are some third-party tools like Pgtune, Cybertech Configurator. You can use these. Like you can supply your information for the server, like RAM, CPUs, what type of workload it is, OLTP versus OLAP, and then it's going to generate a custom config file. Of course, you need to benchmark and see if that is good enough for you and make further changes. These are the two third-party tools you can use. Sure. No, it doesn't have for everything, only some. Like for example, workmem, you can do dynamic. Shared buffers, you need to restart. Yeah, some of those. Like if you want to add an extension, you need to restart. So yeah. So here is a summary. PG settings is equivalent to $$ parameter in Oracle. And then set session and alter session are equivalents. And Oracle has P file, SP file, Postgres doesn't have that. And as we saw, Pgtune, Cybertech Configurator can be used to tune your config. And Oracle has some additional features which are missing in Postgres. And then the next topic is Postgres security. So data breaches are pretty common these days. As you know, T-Mobile breach was pretty popular in media these days. And the average cost of a data breach in US is 9.4 million. Globally, it's 4.4 million. Not only the money, right? The brand reputation is hurt once there is a breach. So what can the hacker do, right? So the first thing he can do is he can use a tool like Nmap to scan for ports, right? The default ports for Postgres is 5432. And everybody knows that, and you'll try to scan for that. Once they identify a server, with a port open, right? They will try the common usernames like admin, Postgres, DB, etc. Once they get a match, they try to crack password, right? And once they crack your password, they're in and they can steal your data. So the common usernames, right? Postgres, admin, administrator, DBA. If you're using WordPress, sometimes you see WordPress or the application user. Ansible, if you are using Ansible monitor. So don't use the common usernames. Try to customize and use some usernames which are hard to guess. And small quiz. Can you guess like how much time it's going to take to crack this password? This password is 8 letters and it has capital, small, numbers, and special characters. Any idea like how much time the hacker would take? Actually, it takes 39 minutes. Into yeah. How about this one? Like it's a 7 letter. It's almost the same as before. The only thing is 7 letter. 31 seconds. Yeah, so this is stats published by Hive Systems for 2022. You can see the rightmost column is the one we were checking, right? So we had numbers, upper and lowercase letters, symbols. You can see the 8-letter ones, it takes 39 minutes, and 7-letter, it only takes 31 seconds.
Does Postgres have some extension or plugin to, I'm comparing with MySQL. MySQL has a plugin that after the third error, because for these they have to do brute force.
Brute force, yeah.
But MySQL has a plugin that adds latency on the reply to the customer after third or fifth attempt, and you can choose to start the range from 20 milliseconds to 2 seconds.
Yeah, there is something called auth delay. You can check it out. Yeah, you can use that to prevent those kind of things. Yeah, it has auth delay. Yeah, but I mean, I would say MySQL has a little more plugins in security than Postgres. But yeah, auth delay is the one you're talking about. Yeah. The common usernames and passwords, right? So this repo, right, you can make a note of this repo. It's called Daniel Missler checklist. So this has all the common usernames, all right, common passwords, passwords already cracked, passwords discovered in breaches. So it has ton of information for you, and it's pretty popular repo for security people. And I mean, if you are particularly concerned about security, you can write a script that tries to match these common usernames and passwords with yours and do some checking there. And then one question is, definitely as DBA, you may think you're talking about usernames, passwords, but in the first place, how can the hacker get in, right? We are using VPN, he cannot anyway get in. But take this case, right, Colonial pipeline attack that happened recently. In this case, there was a compromised VPN account, and that's how the hacker got in, right? So yeah, there could be some edge cases that allow the hacker to get in. And then take the case of T-Mobile, right? This happened in 2021, and this is related to databases. The hacker was able to get a hold of a GPRS node, and then he pivoted to private network where DB servers resided, and then he accessed the Oracle DB using the brute force, and then he stole the data. So DBAs play a pivotal role, right? Because the end target for the hackers is to get the PII information or the credit card information. So don't think that DB servers are always secure because you're using VPN, MFA, etc. Use strong passwords and auditing and alerting on unusual activity. Postgres has PG audit extension for that. And then use SSL encryption, security policy. Of course, having policy is one thing, but enforcing on all the servers is a totally different thing. And then optimize your HBA for Postgres. Optimize pgconfig least privilege role, as you know, give only the privileges that the user needs. And then use something like YubiKey for as a physical device in addition to MFA, because that will enhance the security posture. And there are more, right? So HBF file is pretty important in Postgres. So you need to check your HBF file for vulnerabilities. For example, you shouldn't use trust, which is very insecure. And then don't use all for your database user and IP address columns. Give the specific usernames or databases that you need. And then instead of MD5, it's better to use Scram SHA. And then a lot of people still use the peer method. They think it's secure, but according to PCI, even this is not super secure. And then ident and password methods are also not secure. And if you want to enforce SSL, use host SSL in the HBA instead of SSL, and then don't give access to all IPs. Instead, give to particular IPs or IP range. We have this open source tool called CloudDB Shield, which automatically checks for issues with your HBA and generates a HTML report if you want to check it out. And then moving on to the next topic, backups. As you know, there are two different backups, logical backups and physical backups. So Oracle, people use Datapump and EXPDP for taking a backup. In this case, we are taking a full backup using the full equal to Y clause. And then the equivalent in Postgres is using Pgdump -d database name. How about backing up a list of tables, right? So you can do that using tables clause in Oracle, and the equivalent is -t followed by the table names in Postgres. And another comparison diagram, if you want to back up a specific schema in Oracle, you can do using the schemas flag, and then the equivalent is -n in Postgres. And let's say you want to only back up the schema, right? Not the data. You can give content equal to metadata only in Oracle. The equivalent is schema only in Postgres. And also you can enable parallelism in Postgres using the -j option. So we talked about backups. Now moving to the restores. In Oracle, IMPDP is used for restores. And then the equivalent is PG restore in Postgres. And if you want to do a single table restore, you can use the table clause in the PG restore. And then again, a comparison diagram. If you want to restore only data only, you can use the data only flag. If you want to replace existing data, you need to give the clean option. And then for parallelism, you need to give the -j. I'll take a quick water break, sorry. So coming to physical backups, there are a lot of options in Postgres. I think in MySQL world, you pretty much use extra backup or MEB, right? So in Postgres, there are more options like PG-based backup, Pgbackrest, VALG, Pro Backup, and Barman. So we did an online poll, and there were about 124 people who responded, and then you can see that Pgbackrest is the popular one. About 50% of them are using Pgbackrest, and 31% are using PG-based backup. PG-based backup is the native backup utility. So for simple use cases, right, you can use PG-based backup, but it doesn't have incremental backup feature or parallelism, etc. So here is the comparison between PG-based backup and Oracle RMAN, like how do you take a backup. And then the restore, right? So Oracle, you can use duplicate database or step-by-step restore method. For PG-based backup, restore, all you need to do is move the files like you do in the, I think, extra backup. The next one is Pgbackrest. As discussed, Pgbackrest has more features. Like if you want to use a robust backup tool, I would recommend Pgbackrest. So it has parallel backup feature, full incremental differential backups, backup check, etc. So one thing with the config is you need to specify a stanza for each cluster. In this case, I only have one cluster. So the PG1 path is the data directory location, and the repo path is the backup path. So if you have multiple clusters, you need to have multiple stanzas. So here is how you take a full backup with Pgbackrest versus RMAN, and then the restore part. So yeah, one good feature with Pgbackrest is incremental backups. So if you want incremental backups, you need to use this. And here is the comparison diagram between Oracle and Postgres. As you can see, the logical backup or the Pgdump is used to take a partial backup. Let's say you want to only backup one or two tables, right? The other things won't work in that case. And for incrementals, only Pgbackrest is used. So now a quick break. So DBA role is not going away. So just watch this. So yeah, definitely it's not going away with serverless or the cloud. So the next topic is the Postgres log, which is pretty important. So once you log into a server, how do you check the log location, right? You can use the show log directory command in Postgres versus the command for Oracle on the left side. So in Postgres, there are a lot of parameters for log, right? So that is one difference when you compare with Oracle. So for example, this is one important parameter which says, which specifies the format for the log file, right? In this case, the default is %y, which is year, month, day, and followed by the hour, minute, second, right? So the default is good for most of the use cases. So there are other parameters like this, like you want to rotate based on the size of the log file, you can tweak that top parameter, and then based on age, the second one. And then the third one is pretty important, right? So if you want to automatically delete old log files in Postgres, you need to use that parameter. So if there is a file with the same name, it's going to delete it. So let's say the Monday log file is termed as Postgres Monday, and the next Monday comes, it's going to overwrite it if you use that parameter. So another quick quiz. So you log on to a server, and here are the parameters you see. Can you guess like how many days of logs will be retained in this case? So again, the log truncate or rotation, like I said, if the log file name is same, it's going to overwrite it. And the log file name in this case is %a, which means for Monday, you'll have a log with the name Postgres-Monday, and Tuesday, like that. And then we are turning off the size-based rotation here. Can you try to guess what's going to happen in this case? How many days worth of logs are retained on disk if you use this? It's going to be 7 days, because if you see, we used %a, which means for Monday it will be Postgres-Monday, Tuesday it will be Postgres-Tuesday. But when the next Monday comes, because we had the truncate on rotation as on, it sees the same file name, it's going to overwrite it. So that's why, you can use these to automatically delete old log files, right? I think in MySQL, you use expire log days for binary logs, right? So yeah, I would say something similar to that. So, and then another scenario, when you compare with the previous one, right, we see the log file name format is changing here. I would say that's the only difference. Can you guess like how many days in this case?
365 is a full year.
Yeah, so yeah, because yeah, because the name is unique for each day, so it's not going to delete. You need to use some cron tab script or log rotate to delete, in this case, old log files. And another important parameter is logline prefix. So this is pretty important. It's going to add metadata to each line in the Postgres log. The default is %m, %p. M means timestamp, P means process ID. But there are other flags you can give: username, database, application, etc. So the recommendation is to use something like the one we gave in the bottom of the slide. So let us illustrate that with an example. So let's say you go with the default, right? %m, %p, and somebody drops the table and you're pulled into a bridge call and people are asking you who dropped the table, right? So you go to Postgres log and all you find is the drop table statement followed by the timestamp and process ID. So you're not going to get much information there, right? So that's why don't use the default, instead use a recommended value like this. So because it's going to add a lot of metadata about the user, application, even the IP address. In this case, we were connecting from local, but in real time it would be some client IP address, right? So it's going to give you enough information to troubleshoot problems. And more logging parameters. So let's say you want to add a lot of information about the connections and disconnections for your security. You need to turn on the parameters for that, and then you want to log information about temp files. You can do that, and auto vacuum, etc. And then quick comparison. You can see that there are a lot of parameters related to Postgres logging, unlike Oracle, and Oracle has trace files, dumps, etc., which are not there in Postgres. And in both Oracle and Postgres, you can use Linux log rotate. And one more quick video. So basically, Oracle has everything built in, right? Like rack, data guard, etc., right? But Postgres, we use a lot of third-party tools, extensions. For example, PG audit for auditing, PG stat statements. There are a lot of extensions people use. So that is one difference when compared to Oracle. So another poll we did, and you can see that about 50% of the people are using 3 to 5 extensions, right? And 25% 2 or less. So people use a lot of extensions. As you can see, some people are using 6 to 10. That's a lot. And then I think the last topic, I don't want to bore you. So the replication, right? We have two types of replication primarily, streaming replication and logical replication. About 50% of the respondents were using streaming replication, and 40% were using both logical and streaming. And there are other types of replication like XDB, which is like a commercial version from EDB. And then BDR is also like an enterprise version from EDB and Bookard others. So again, for the failover and HA, there are different things people use in Postgres world. Patroni is the most popular one, and which is really good to avoid the split brain scenarios. And then people also use PG Bouncer along with HA proxy, sometimes rep manager, but rep manager in some cases can cause split brain. PG pool, like in MySQL world, use proxy SQL for read write split. You can do that with PG pool. EFM is again like EDB tool, like it's kind of a paid tool, I would say. When you use EDB version, you would use EFM, which is equivalent to maybe rep manager. And then PG auto failover is another one. Coming to monitoring and tuning, these are some of the tools that you can use within Postgres to monitor. PG stat statements is an extension that you need to load. And PG stat activity. PG stat activity is used to check in real time, like you do show process list in MySQL, right? The same thing with the PG stat activity. But if you need history, right, like what happened yesterday, last week, you need to go for PG stat statements. And then there are other stuff like if you want to get database metrics, PG stat database, and there are other stuff for logs, etc. And then the logs, right? Postgres logs contain ton of information. So here are various fields if you want to understand what pgstat activity does, like database name, paid username, etc., client address. And then also when the client backend started, the transaction started, etc. Some of the queries that you can use for your troubleshooting. For example, if you want to get total number of connections using pgstat activity, or grouped by client or for my particular client, etc. And then you want to know for a particular database, you can group by database or give the particular database, and then again by username. And this slide is pretty important. Like, when there is a problem, you want to find the slow queries. So you can run the one on the top to find the slow queries at the moment. And then you want to know any idle transactions which are sitting idle for more than 5 minutes, you can use the next query. And then if there are any queries in waiting state, like a lock wait or other wait, you can do that using the next query. And then I discussed about Pgstat statements, right? This is when you compare with activity, this contains the historical information. So you want to list top queries for a particular range of time, you can do that, and also queries using a lot of time space, the second query. And IO intensive queries, these days IOPS are pretty important. You can use this query to group by IOPS, and then IOPS usage, and then memory usage. I think that's it, guys. So if you want, check out our, our various tools.
I have a question.
Sure.
So on your security slides, when you were comparing, like, I guess what was important on the Postgres side, you mentioned encryption. I'm assuming you talked about it, or people migrating to Postgres or whatever. What are they using for like encryption at rest when they get off of Oracle and go to Postgres?
Yeah, that's a challenge. Like Oracle has TDE and Postgres doesn't have. But EDB, I mean, if you're using EDB version, they came up with TDE equivalent, and also there is some company called, I think, Cybertech or somebody. But if you want to go with the open source, I think you need to use HashiCorp Vault or something like. But there's nothing like open source, which is really robust at this point of time.
Yeah, okay, that
Yeah.
makes sense. Your poll about replication, it said like 40% of the respondents were using both streaming and logical. Are they just, what are the use cases for doing that?
Because logical is like if you want to just replicate subset of tables, like if you have a reporting instance and you don't want all the tables, in those cases only logical can be used. So yeah, streaming does for everything. Thank you. Thanks for attending the session. Hope you may. Thank you.